Well, good afternoon, and welcome to today's webinar, Optimized Connector Solutions for Consumer Electronics Hardware Designs, sponsored by the following Hirose franchise distributors: DigiKey, Mouser, Future Electronics, Sager Electronics, and Highland Electronics, who are all authorized to sell the portfolio of Hirose interconnect products. I'm Bill Kysiak, and I'll be your moderator today. We have a few brief announcements before we begin. First, this webinar is designed to be interactive, and we encourage participation in the Q&A session that will take place at the end of our presentation. You could submit questions at any time in the chat area, and please note that we'll get to as many of the questions as we can in the time we have left at the end of the program. However, if we don't get to your question today, someone will get back to you after the program has ended. And by the way, when you submit a question in the chat area, it is confidential and not seen by the entire group. Hirose will have sample kits available which demonstrate the products discussed in today's webinar. We will be sending you a follow-up email. If you'd like to receive a sample kit, please respond with your mailing address, and we will be happy to send you one. If you want to view in full screen mode, click on the tab with the three buttons on the right side of your screen. And now, for today's presentation, Optimized Connector Solutions for Consumer Electronics Hardware Designs. Discussing today's topic is Mark Waring, Strategic Account Manager at Hirose, providing marketing support for Hirose's RF, 5G, and consumer electronic solutions. Mark is a graduate of San Diego State University with a Bachelor of Science in Physics and an MBA from Pepperdine University. Mark has held various technology and business roles in the Silicon Valley for the past 20 years. It's with great pleasure I now turn this special session over to Mark. Mark, take it away.
Great, thanks, Phil. Let me share my screen. Okay, so should be able to see my title screen. If you can't, let me know. Thanks, Bill, and thanks to everybody for taking the time to join us today. Today's webinar, as stated, is a somewhat broad overview of the latest consumer electronics connectorization roadmap solutions from Hirose Electric. We claim to be the leading internal connector supplier to Tier 1 consumer electronics device manufacturers around the world. I'll strive to stay within our 45 minutes. And as Bill mentioned, time permitting, we'll answer a few questions at the end as well. So let me start by throwing an eye chart at you, which is just a small subsection of some of the new products and upcoming products that are in our Hirose roadmap. Today, we're going to move pretty quickly, sharing an overview of the general connector landscape and how Hirose has and continues to pioneer developments which allow connectors to keep up with end product challenges. But instead of going over details of product roadmaps and descriptions, we'll instead group some of our latest solutions to cover these three specific areas of current interest to the industry. Small form factor requirements, or very small form factors, or we could even say micro form factors, as we'll see. Integrated shielding structures, meaning literally shield structures that are embedded within the connector itself. And finally, a brief overview of a few additional trends and new solutions that are influencing successful CE designs. First and quickly, a little necessary background. Hirose was established back in 1937. Today, we're headquartered in Yokohama, just outside of Tokyo, and we have some downtown Tokyo facilities as well. Within Japan, we have multiple large-scale manufacturing sites, which are strategically located in separate locations across the country, including one at Koriyama, one at Ichinoseki, and multiple facilities in the northern part of the main island of Japan, Tohoku Prefecture. In addition to our domestic Japan manufacturing footprint, we have over the years built out multiple Asia-based facilities, including a major design and manufacturing subdivision in Korea, additional in-house manufacturing and assembly facilities in China, Indonesia, and Malaysia. So with Hirose, you do get a supplier who can provide geographic redundancy and flexibility, which is probably more important today than ever, all under a single world-class branded quality control and logistics operation. Hirose is a pure-play connector supplier, meaning all of our manufacturing capabilities are allocated entirely to support our commitment to you, our customers. We channel our output directly to serve you with no internal connector usage of our own, no competing products, including added value modules or subsystems vying for IP or capacity, and no downstream finished product commitments or conflicts in our design, production, and support chains. Within the overall market, we of course have different product divisions, which include engineering, specialized manufacturing, marketing, sales, and support teams dedicated to the following major segments. Automotive, at around 20% of our business, is a fast-growing part of our overall business. Industrial, which we define to include many finished product segments as well, including medical and office automation products, for example, makes up an even larger, over a third of our overall business. But consumer electronics continues to represent the largest portion of our business, serving the entire breadth of evolving consumer electronics devices today. But before moving on, a quick clarification to some of the types of solutions we'll be talking about. Board-to-board, or B2B, as you might see it abbreviated sometimes, is used to describe not only a true board-to-board interface, but today in consumer electronics products, it's probably more likely to be utilized as a board-to-flexible printed circuit cable, or FPC solution, which is surface-mounted, just like a printed circuit board. Another major category are ZIFs, or zero insertion force connectors, which typically include a mechanical actuator or lever to compress and hold a mated cable in place, or some novel new designs which automatically close and lock, like one we'll look at a little bit. Board-to-wires, which are not given as much attention in today's presentation, nevertheless are a very widely used solution in consumer electronics, spanning from true micro solutions on up in size. Board-to-wire solutions can include discrete cables with crimped or soldered contacts on the end to seat inside the plastic connector housing, pre-joined ribbon cable styles, or ganged, individually shielded micro-coax styles. Finally, Hirose has led the industry in introducing direct surface-mounted micro-coax single-path solutions, primarily for RF antenna or radio signaling. All of these just mentioned types are found in many CE devices today, and Hirose commands a leading market share globally of these solutions found inside virtually every flavor of consumer product. From the smartphone on your table or desk, including the earbuds or the headset you're using to listen to this call, to the laptop you're viewing and the router getting your signal, to your various connected smart home devices such as speakers, maybe even your coffee maker, your smart lock, or your vacuum cleaner. Besides our strong product mix and aggressive customer-driven new product developments, we earn our design wins by being responsive to individual customer needs and by bringing our knowledge of industry-specific needs to the table from day one. Here in North America, we go beyond selling through a list of Japan-designed parts to working locally with large and small customers to understand their engineering criteria for success on specific designs and responding with our own analysis and optimized solutions, which may include our latest standard solutions, or one of our many new designs hitting the market each year, or working to find a new solution specifically tailored to your product requirements. This process also often involves working with our customers to help analyze and optimize not only our connector component, but directly related subsystem elements. So what do I mean by that? Well, high frequency, demanding form factor product designs increasingly need to consider subsystem or full system performance factors, not simply individual component specs. At Hirose, We get involved with our customers, offering design guides for general designs and custom discussions and support for specific design requirements. This often starts with PCB or printed circuit board analysis, including things such as ground via optimizations, PCB side plating effects, stitching via locations for coplanar waveguides or even embedded traces, glass weave style effects of the PCB, more subtle via stub effects, and other PCB material influences. At a higher level, we can even go beyond the connector's printed circuit board interactions and help analyze and optimize full subsystem performance. This may include signal integrity analysis for combinations of components, whether an analog high-frequency path is shown here, or a digital high-frequency microboard to FPC solution, or a full subsystem environmental performance consideration, including increasingly concerns over external radio emissions. Our recent work on 5G radio applications is a great example of this type of performance modeling, taking into account effects of the connectors, PCB, and FPC cables all in concert. This support comes from technical staff, not only at our factories in Japan, but located throughout our US locations, but also includes a team here in the heart of Silicon Valley, which includes our own local hire signal integrity engineering group. This group serves customers throughout the country, focusing on high-speed design projects, both digital, from small up to massive server back-end interconnects, and analog, working on largely millimeter wave domain component, board, and subsystem projects. So with a few introductions out of the way, let's move on to what's driving some specific CE design challenges today. The first sub-theme is perhaps the most obvious, but also perhaps the most important, with CE devices continuing the move towards sleeker, smaller form factors, as well as new CE applications, which inherently demand smaller form factors. Earbuds, a great example of one that has exploded in recent years. Small form factors are critical to a wide array of consumer products. The smartphone is still a great example of an evolving platform that pushes component requirements to greater levels year after year. Whether display, camera, or other module-level system requirements, antenna and radio paths, touch panels, sensors, and inputs, to general I/O connectivity, and power or battery paths. For any and all of these, we regularly introduce new series with feature improvements to keep pace with this benchmark device for the OEMs around the world. We've been a leader since day one in this market, bringing our existing core competencies to bear, both from design and manufacturing perspectives. We focus on high volume cost reduction and quality improvements together. A great example being our leading the industry beyond injection molding to complex metal insert mold structures, which we'll describe a little bit later. At the same time, we continuously modify and enhance the internal elements of those structures using advanced simulation and modeling to push critical factors such as impedance matching, high frequency response, increased current and power management, and just as critical, environmental requirements, from higher temperature support to hybrid signal structures, all in smaller and smaller footprints. So what's the first challenge in a small form factor? Well, the most obvious, again, is probably the X and Y space constraints. Let's consider an even smaller product than a smartphone in a smart wearable device. These devices are adding more functionality and features with each new generation, including high-resolution displays, touchscreens, increased internal processing power, etc. The product itself is already squeezed and being squeezed to smaller outer form factors. And therefore, the signal paths inside at every level are being squeezed more tightly. The footprints within these small architectures are being reduced in size. And additional connections are proliferating within the devices. Hirose claims unmatched leadership in the arena of XY form factor solutions, with a progression of ever smaller state-of-the-art form factors from widths of 2.6 millimeters. And to clarify, by width here, I'm talking about the maximum outer dimension of a mated pair of connectors, to 1.98 millimeters and 1.7, and some of our very latest down to 1.5 millimeter total width, all while maintaining a highly manufacturable 0.35 millimeter pitch for the internal contacts. Together, these examples represent the state-of-the-art in pitch and length and unmatched worldwide leadership in the critical width dimension. This progression of industry-leading form factors is greatly aided by utilizing our proprietary insert molding, which is utilized at all of our factories today. Previously, and still used exclusively by many of our competitors, is a manufacturing technique called press fitting. Starting with an already plastic injection molded piece, separate metal contacts are press fit to the plastic, essentially like clipping a paper clip onto a piece of plastic. These are combined to form a connector element, but leave limitations on both mechanical accuracy and mechanical stability of the two mated pieces. A second challenge in press fitting is the fine dimensions of plating the small contacts, which require gold or other conductive layers on the exposed mating elements and a resistive coating, usually nickel, on the internal sections. This introduces another level of imprecision due to the small geometries involved. Hiroshi has led the industry starting back in 2011 with the introduction of insert molding. In this case, the metal contact structures are actually placed within the plastic injection mold, meticulously held in position as the mold is sealed and filled, resulting in a perfectly aligned and fixed metal contact landscape embedded within the rigid plastic itself, easily taking the precision from an order of magnitude of tenths of a millimeter to hundredths of a millimeter, both in terms of contact positioning and plating area control, which here is pre-delineated by the embedded plastic borders. Since leading the way in bringing insert molding to the high volume manufacture of microconnectors, we've continued to refine and extend our capabilities, including a growing offering of micro board-to-boards, insert molded micro-coax RF solutions, as well as applying insert molding to new classes of connectors, including zero insertion force solutions. In addition to insert molding, another very new series, the BK13C, represents another new design direction, again, led by the needs of our OEM customers. The BK13 utilizes a ruggedized construction, which we call fully armored. A typical board-to-board microconnector will have plastic exposed on either end or both ends, on one or both of the mating pieces, leaving the real possibility of damage during mating, whether that's manual mating or automated. Partial armoring may protect the end caps, but leave other plastic surfaces exposed. Our aggressive, fully armored design introduces a complete metal jacket on both mating pieces, assuring only metal on metal during mating and unmating, significantly reducing the possibility of damage and the consequences of plastic breaking during product assembly. So the next logical challenge in small form factors, and one that often drives the final connector selection, is vertical height, or the Z dimension. If we consider a smartphone or tablet, it's clear how constrained the Z dimension can become. The overall outer dimensions are already limited by design. And within this limit, there are often multiple stacked subsystems, including displays, touch panels, modules, and circuit boards. And within these layers, multiple signaling paths often must be accommodated, and multiple path types, which often require multiple connector and cabling integrations. Hiroshi has once again helped lead the migration to ever smaller stack heights. And again, in this case, by stack height, we mean the maximum vertical outer dimension of a mated connector pair. From our BM23, which was introduced at 0.8 millimeter total stack height, to the BM25 at 0.7, to the BM28 and our world's narrowest BM29, both achieving 0.6 millimeter total stack heights. An important related stack height challenge we've increasingly recognized and helped address is the need not only for ever smaller height connectors, but some flexibility for addressing multiple stack heights within the same or similar families. The BM28 is one of our first examples in this direction, which has been introduced now with two separate stack height options, 0.6 millimeters, matching our latest low profiles, as well as the 0.8 millimeter option. The benefit of variable heights is easily demonstrated by considering one of the multiple signaling path scenarios mentioned on the previous slide. If two paths are populated on a circuit board layer with overlapping cabling, stresses on one or the other are unavoidable, and the integrity of either the cable itself, the connection, or both may be seriously compromised. With the option of variable stack height connectors, it's just as easy to see that margins for crossing signal paths may be met, removing the vertical path interference and its negative effects on product design. Another real-world result of this may not be a perfect vertical alignment, but now perhaps some extra space, which in this case is easily complemented with passive padding or cushioning, maintaining again an ideal vertical alignment. In other cases, it may not be cross-signaling paths themselves, but other adjacent board-mounted component heights, which may require a variable connector height option to optimize that vertical alignment. At the same time, the path to even smaller height connectors continues, and we will introduce our next evolution in this direction within the first half of next year. So to step back for just a second again, and for a little perspective, since we're talking about small form factors, here's an example of how one of our micro-connectors stacks up against a cent. And this, by the way, isn't even one of our smallest length connectors I grabbed, but the truly small scale involved is still clear. We can look at the same comparison in terms of height, where our latest family of 0.6 stack heights could actually fit two stacked pairs within the thickness of the same penny, which, for your reference, is about 1.5 millimeters thick. Another addition to small stack height options, which we've just introduced this fall, is the world's smallest height micro zero insertion force connector, the FH64MA, at only 0.5 millimeters total height. This world's lowest stack height ZIF includes important features, such as wide guidance structures to aid consistent insertion, middle, tab, or hooked FPC support, meaning metal spring-loaded tongues, which hold the FPC cable in place with high retention force, even for low pin count requirements. And notably, we've included staggered contact rows inside the connector, allowing, for example, an FPC with tolerances equal to a typical 0.3 millimeter pitch to support a 25% narrower pitch of 0.25 millimeters. This relaxed FPC tolerance translates directly to lower FPC manufacturing costs at the same time. Before we leave the topic of variable height solutions, it's worth introducing a couple more popular and recently added families which address this same challenge. The DF40 is what we might call a small versus micro-sized connector family. It's one of our most widely adopted series. It's something of a Swiss Army knife in offering several options within one series. And one of these options, which we have extended recently, is the choice of multiple stack heights, accomplished by switching only one side of the pair. These variations span from 1.5 millimeters up to 4 millimeters. Clearly not for the smallest form factor CE devices, but well suited for smart home, PC, audio, video applications, smart speaker, and more. We've also recently introduced an active locking option to this family, higher temperature rated parts, and these all come in a very wide variation of pin counts, from 10 to 120. We'll be announcing even more variations to the DF40 family within the next few months, so stay tuned or reach out if you have any specific questions. A second family worth an even quicker look, even though it extends into the larger size class that we would in Hirose denote as industrial, is the FX23 series. Like the smaller DF40, the FX23 is similarly designed to allow many different stack height options, in this case through multiple possible combinations of both the header and the receptacle. This larger series is typically used as a true board-to-board solution and offers true active floating mechanisms on either or both mating elements to allow a 1x or 2x range of active floating tolerances in the x and y dimensions. This quickly becomes critical when multiple connections between two rigid PC boards are involved. And like the DF40 family, this larger FX23 series is offered in a wide and well-populated assortment of pin counts from 20 to 120. Still on the theme of small form factor, we see consumer device designs requiring greater and greater power or current management. At the same time, size needs to be minimized. This can be due to more power-hungry elements, such as high-power resolution displays, cameras, or other subsystems, wireless radios and supporting circuitry, and perhaps most obviously, related high-power direct battery or line power paths inside the device. If we look at the same sequence of series I showed already, this time from right to left, we can see where Hirose once again offers the very highest current ratings in these small form factor classes, from 3 amps for our very smallest solutions to 5 and 10 amps for our some still in that 0.6 millimeter height and 2 millimeter width ranges. And these very high levels of integrated power are made possible by the novel inclusion of end metal structures, which double as mechanical reinforcements and dedicated power rails, combined with dedicated oversized solder pads. On the same theme, sharing another just introduced series, the BM56 series, it takes the focus on power to an even higher level, supporting up to 15 amps, and still combining this capability with digital signal support integrated, and all in an industry-leading form factor of only 1.65 millimeters total width. Another trend in small form factors that is clear is the growing integration of the latest high-frequency RF signaling technologies. RF communications are increasing in usage, with personal electronics adding the latest cellular and Wi-Fi signaling support, smart home devices adding stronger and higher frequency signaling, and routers, repeaters, extenders, and next generation fixed wireless equipment, all adding even more RF signaling requirements to these devices. Hirose, once again, has led in introducing our first high-frequency analog RF optimized micro board-to-board or board-to-FPC connector series in 2016, the BM46. The BM46 brought analog RF optimized contacts and mating structures to a traditional digital micro solution. The result is optimal RF signal integrity transmission up to 10 or 12 gigahertz. This series also introduced internal crosstalk mitigation, adding an insert molded center shield between the two rows. This results in minimized fixed or next crosstalk between RF signals placed on opposite rows, as shown in this simulation. This new capability can come directly back to space savings at the same time. A typical radio transmission module design will include RF cabling, here shown with 2 micro-coax solutions for transmit and receive, combined with a digital micro board-to-board for routing associated control signals and possibly power as well. By enabling RF directly in the same optimized solution, the digital, power, and RF signals may all be routed together in a single path. This can reduce the effective board space allocation by as much as 2/3. The BM46 addressed RF signaling quality and internal signal-to-signal crosstalk. Today, we're sharing for the first time publicly our about to be released next generation BM56 series, which adds full 360-degree metal shielding and takes the RF performance up to 20 Hz. While the BM56 is being released, we're already preparing a third-generation solution, which we'll be releasing in 2022, and which we can share more details with you on an individual basis if interested. Another important trend that the BM56 segues to is the emerging interest and need that we are hearing from our customers for internal shields integrated into the connector itself. Not only is internal noise suppression, but external RF emissions is a new trend as consumer devices incorporate more and more radios, or in some cases, not even RF signals, but high-frequency digital differential signaling paths. The image from the previous slide is a good picture, but with more than simply RF analog transmission in mind. Radios are being added to the smallest CE devices today, spanning from Bluetooth frequencies to the latest Wi-Fi standards, all the way to 5G sub-6 and 5G millimeter wave. At the same time, multiple radio paths are being added to the same end products. The higher frequency is increasing the control chip and circuit trace radiation concerns at the same time, resulting in not only internal but also external interference challenges. Going, again, as I mentioned, beyond just pure analog RF. To simplify, the end goal that customers are after is something like a traditional shield box effect, but integrated into the very small form factor connectors themselves. Hirose was an early pioneer in considering the first mass-produced shielded micro-connectors, specifically for RF signaling, with our introduction back in 1990 of the now de facto industry standard form factor, the Hirose U.FL series. The U.FL includes both shielded micro-coax cables together with a tightly coupled connector plug and PCB-mounted receptacle combination to achieve RF signal performance to 4 or 6 GHz. This family continues to evolve with smaller form factors and higher frequency support to 8 and 12 GHz. And more recently, we've gone back and redesigned a new intermatable U.FL plug and cable assembly with much more aggressive shielding, bringing the signaling performance capability up to 15 GHz. And finally, even more recently, this past summer, we launched a new shielded micro-coax solution in a smaller form factor, which carries this family into the 5G millimeter wave domain with the introduction of the shielded C.FL, rated up to 30 GHz transmission. But as shown previously, a big trend in routing RF signals in small CE devices is combining shielding structures onto micro board-to-board or board-to-FPC solutions. We can take a little closer look at the BM56 to see how this is accomplished and its benefits. The BM56 adds something closer to that ideal shield box structure I showed earlier, in this case via a double shielding structure with full 360-degree metal surrounding both the receptacle and the header. When mated, this pair, in concert with properly shielded PCB layouts and shielded FPC cables, achieves multi-RF signal capability with excellent signal integrity performance up to 12 GHz. And all this added structure is within a width of only 2.2 millimeters, unmatched for such a hybrid shielded structure today. The shielding can be seen to mitigate radiated emissions, both from a side view, shown here, and a top view, with the double wall structures effectively blocking internally generated noise. From what I covered already, maybe you already noticed that this new RF solution also incorporates the latest full armor design ruggedization, with full metal protection designed into both receptacle and header mating areas. The BM56 also provides a tactile click mating, with a détente and dimple combination providing secure seating and retention. The BM56 also includes metal guide ribs built into the shielding structures themselves. This provides an aggressive self-aligning range of 0.3 millimeters, nearly an entire pin offset, in both the length direction and the width dimension. Finally, these close-up images of the BM56 are a good place to point out one other advantage of insert molding. The metal embedded directly into the plastic formed housing on both header and receptacles leaves no gaps for potential solder wicking during soldering to either a printed circuit board or flexible printed circuit cable. As shown on a previous slide, our RF board-to-board family will include a new introduction, one which very much involves further enhancements to the integrated shield structure. In addition to higher frequency signal integrity support, in this case targeting up to 30 gigahertz, this even more robust integrated shield structure will further enhance mitigation of external EMI. The interest in integrated shielding is driving us to introduce additional families of shielded board-to-boards, in the case shown here for the small size CE device market. Recalling the DF40 family, I already introduced our Swiss Army family due to its many variations. Yet another new variation this year, and supporting many of the other DF40 feature options already discussed, is the new shielded DF40G series. The DF40G provides a similar dramatic reduction in external radiation. In this example, over 18 dB reduction at just under 5 gigahertz. It's available in a variety of height selections and with a variety of pin counts and with support for multiple high-frequency digital signaling protocols. Additional currently available shielded connector options include shielded FFC or flexible flat cable connectors, with our FH41 or 46 offering shielded FFC support in horizontal orientations, and our FH48 and FH67, one of our new one-action ZIFs we'll describe later, supporting shielded FFCs in vertical orientations. The KP27F is another recent addition, adding a full metal jacketed shielding structure and dedicated power pins to our FX23 floating board-to-board family. Like the FX23, this new series supports active floating, but also adds automotive-grade temperature rating and comes in a 21 millimeter stack height. Also available now are ganged and shielded micro-coax solutions, shown here in a tight 0.4 millimeter pitch configuration, and here with an even tighter 0.3 millimeter pitch support option. Lastly, let's look at a couple additional feature trends which are influencing successful CE connector projects. First, a brief look at a new family of auto-locking ZIF solutions, which we call our One Action series. If you've ever worked with a ZIF or an FPC or FFC cable assembly, you'll recall there's always some sort of mechanical actuator, usually a bar like this, that after inserting the cable, you close manually. This actuator may flip up from the front or from the back. It may be lifted at the edges or at the center, but it's always there and always a necessary part of the mating operation. Hiroshi introduced our patented and industry-unique One Action series in 2018. With the One Action solutions, the FPC or FFC is simply inserted, period, and if needed, removed with a single manual lift. The mechanism involves spring-loaded locking levers, which are lifted by the cable insertion itself, then automatically fall to close and lock on the inserted cable tabs. This simple design evolution immediately brings multiple advantages, from shipping and storing, to design and component placement freedom, to assembly efficiency. Quickly explaining each of those, typical ZIF connectors require the actuator to be shipped and stored in the open position. Closing the actuator with no inserted FPC cable can immediately degrade the spring contact integrity. Since the one action series don't involve a manual locking actuator, there is no such concern, and both shipping and storing the connectors is simplified, both in terms of damage risks, as well as the efficiency of stacking trays more closely in transit and in storage. So what's the design benefit of our one action? In our one action, since no actuator access is required, design layouts may therefore encroach closely on the connector itself, with resultant small keep-out areas in both the vertical and the rear depth direction. In a typical ZIF design, on the other hand, access to the actuator during product assembly must be accommodated, resulting in much larger footprint allocations in the same vertical and horizontal directions. Finally, the assembly benefit is perhaps the most obvious. The simplified insertion process offers a significant efficiency increase, both in terms of steps involved and in terms of cycle time in high-volume manufacturing environments, whether those are automated or manual assembly. These new one-action series are available in a variety of configurations, including horizontal and vertical configurations. They offer excellent signaling abilities, including customer-specific differential signaling layouts and support for several high-frequency digital I/O standards. Another feature trend that many of our series already offer is superior retention force, meaning the strength against mated pairs becoming fully or partially disconnected. But in some cases, consumer environments demand even stronger, more fail-safe mechanisms. Returning again to the DF40 family, we've just this year introduced an active locking option. The new DF40GL incorporates a keyed positive locking mechanism, which includes keyed latching along the length of the connector and a locking bar for disengagement. The active locking is incorporated fully on one side of the mated pair and increases retention force up to 50 newtons, 2 to 3 times greater than even a high retention force typical ZIF solution. Here's a very quick look. Let's see if I'm going to get that to work. There we go. Here's a very quick animation of showing how this works. And it's truly like a lock and key process, very different from a typical high retention force ZIF connector, and one that's really targeted at applications where a secure locking mechanism is critical. You can see here the entire locking mechanism is located on one piece. During mating, it automatically locks. No actuation is required. And the result is something, again, much more robust and secure than any alternative available today in a similar type of connector. And let that wrap up. More ruggedization is always good, and we've been pushing the environmental characteristics at the same time, with temperature being one key factor, where certain environmental characteristics, such as power tools, certain environments, such as power tools or robotics, may require greater temperature margins. While we have a large and growing offering of high temperature rated solutions under the umbrella of our automotive portfolios, we're recognizing the desire from CE customers to consider these ruggedized high temperature solutions for certain CE applications. One example is the FH65 ZIF, only 1.2 millimeters in total height with 0.5 millimeter pitch and excellent retention force, and rated to a full 125 degrees C. Within our new one action family I just described, we've included two series, the horizontal FH63S and the vertical FH67, both of which are rated up to a full 125 degrees C operation. And once again, the DF40 family is a final good example to showcase a recent extension of CE connectors with new auto temperature grade variations. The DF40T series, introduced this year, meeting, again, the full 125 degree C temperature range of operation. These new DF40 options I wanted to mention are more than just a simple respecking of the same parts. We've gone back to the basic contact structure and redesigned, reworking both the micromechanical form and adding specific plating material and layering changes to ensure a robust high-temperature operation. As a final differentiated example of CE supporting solutions, let's look at a very different connector, a micro-optical board-to-board. The Hiroshi BF4M is a novel micro board-to-board design, surface-mounted like any other, but combined on the header side with an equally small active optical transmitter. Combined with a mating receiving element on the opposite end of the cable, the BF4M allows true optical fiber transmission in a compellingly small form factor. This solution is unidirectional and can be considered when data transmission is heavily weighted for either download or upload. Complex sensor feedback is one example. Or two of these devices can be replicated to achieve bidirectionality. Or we do offer a twin package solution to address bidirectionality as well. The BF4M currently supports 6.25 gigabits per second, and we will be introducing an upgraded higher frequency supporting part next year. This unique offering is an order of magnitude smaller in size than typical board-to-board optical standards, such as the CX3 or SFP standard products, coming in at only 10 millimeters versus 3 to 4 inches. The use of fiber allows flexible routing with no hard routed isolation components and with superior isolation at the same time, for example, from one voltage plane to another. The small diameter cabling is flexible, lightweight, and resistant to EMI interactions or noise. And transmission is efficient from short lengths, cable lengths, to lengths of several meters, with very low power consumption versus alternative optical or electrical long-distance lines. So that takes us to the end of my presentation, and I thought, or I hope, that maybe this connector eye chart I showed in the beginning looks a little less confusing to you now. Maybe you can spot some features even, such as actuators or shielding or critical dimensions that you couldn't before. I hope this overview has given you a better understanding of some factors which can drive connector decisions in your consumer electronics projects, and maybe even given you a little insight into connectors themselves, their categories, key attributes, and important features that can help you make better informed decisions and help you ask the right questions when considering your next design. Certainly, we encourage you to follow up with any questions or requests you may have. We have in-person sales office, most of those including technical staff across the country. Our website is, of course, a great place to start. Right at the top of the homepage, you'll find an easy-to-use product search box. On the same homepage, you might check out the Application tab, which provides overviews with potential series to consider for different product class applications. And the Category tab to the left of that is another simple path to explore our offerings by category, where you'll find the connectors covered in this webinar and many more organized by type and characteristics. When you get to specific product pages, you'll often find 2D drawings and 3D simulation-ready files available to directly download. And from our series pages, you can often find more advanced touchstone file downloads, which are available, like the other engineering files, with a simple registration. Inquiries can be made online as well, though we're available and interested in talking to you in person to understand your requirements and help you find the ideal solutions. Anyone's welcome to reach out to me directly, and I can help get the ball rolling. Thanks again for your time, and let me turn it back to Bill to close things up.
Great. Thanks, Mark. Nice presentation. Appreciate it. And now we'd like to open it up for our Q&A session. If there are any questions, please feel free to pop them into the chat area, and we'll get those over to Mark. Okay, I've got a couple to start with here. The first one is, are your connectors compatible with all the latest 5G standards? Mark?
Well, I guess the answer is no across the spectrum of all the wavelength bands that are currently being used for 5G. A couple of those shielded and RF connectors, including that BM56 I highlighted, was designed with some 5G applications in mind, So you may be familiar, a lot of you, that 5G comes in two flavors as well, sub-6 gigahertz. Many of our connectors, in fact, most of our connectors that I showed today would be perfectly compatible with the 5G sub-6 spectrum. The other flavor of 5G is millimeter wave, and that starts at about 28 gigahertz, true millimeter wave. So, for instance, the C.FL micro-coax cable I showed, it's rated up to 30 gigahertz. And our next generation integrated shield board-to-board that I mentioned, but I didn't share details of today, is also targeting 30 gigahertz performance. So we do have a couple of connectors that today are capable of full 5G support into the lower end of the millimeter wave spectrum. But I will mention, too, that many OEMs are using intermediate frequencies for actually sending those millimeter wave signals back to the circuit board modem chips, for instance. And in those cases, some of these same connectors might already be suitable for use in the millimeter wave domain.
Thanks, Mark. I've got another couple more questions came in here while you were speaking. One is, with the dramatic reductions in board-to-board connectors, are they still handmade? Are they still handmade or unmade, or are there special tools required for mating them?
Oh, that's a good question. These, as I showed you with the little comparison to the US penny, these are tiny connectors. You could almost lose some of them in the palm of your hand. So I won't lie, if you're like me and you've got big fat fingers, these are difficult to play with and mate and unmate. Of course, most of these go into high volume applications where there is automated assembly, but even for some of the high volume CE devices, they are still manually assembled. And in that case, things like the self-guidance ribs that I showed, which is available on many of our series, could be a critical step. But to answer the question about specific tools, in general, no, we don't require specific tools. But in cases, yes, we do. And you can find those on our website. If those are required, you'll usually be able to quickly see those noted as required or available to use, versus using a fine screwdriver, which often works too in an engineering environment. But so the answer to the question is, for the most part, these don't actually require or come with instruments to additional jigs or tools to mate and unmate. But there are exceptions to that, and those are pretty clearly noted on our product pages.
Thanks, Mark. Here's another one. Can I get HFSS models for your connectors for simulations?
The answer is yes, you can. We do offer HFSS 3D models. Often those are encrypted models, and often those are going to require you to get in touch with us. And we'll probably need to know a little bit of details about your product. What's the business opportunity? But in that case, we're more than happy to share HFSS models and probably 90% of our connectors, those exist already. So those are something we can talk about. Absolutely.
Great. Thank you, Mark. A couple more here. Well, someone's asking if we will share the slides, and I'll take that, answer that. Yes, we'll be able to share the slides. As I had mentioned to you in the introduction, we'll be sending you a follow-up email, and in that email, you can request either the sample kit, or if you're interested in the slide presentation, we'll be able to get you a link to share that. Another question here: how much Newton force in the tabs of the BM56G? That's a pretty specific one.
That's a pretty specific one. I won't pretend I know the exact newtons, but I think the BM56G is in the 8 Newton range, plus or minus a couple of newtons. And certainly you can maybe find that out for yourself. If you're interested in looking on the website, and you're more than welcome to get in touch with us, we can share with you the exact specifications for that and other similar connectors. You can take a look and see how it compares with our other families of products. But it's in that range, give or take a few newtons.
Thank you.
Yep.
Is your active locking feature offered for all the various heights in the board to FPC DF40 series?
Answer is no. It's not offered for all the various heights of the connectors. So we need to talk, and I think it's mainly for the lower height connector. I think it may top out at 3 millimeters versus the entire range of DF40, which goes to 4. But don't bank on that. I need to take a look at that with you together, maybe. So, but the answer is no. It doesn't span the entire breadth of the height options for the DF40 family. So there are some limitations on where that active locking feature is available.
Great. Okay. So to the user or the questioner, if you put that question back in your the email that we'll send to you, we'll be sure to get that off to Mark to research that for you. And the last question I've got up here is, are there plans to increase the maximum mating cycle rating beyond about 10 for the B2B BM29, for the board-to-board BM29?
We're pretty conservative in our mating cycle ratings. So I can't speak for our factories whether they're going to officially make any changes. I certainly don't think that's in play today that I know of. But on the other hand, I can also tell you with confidence that on a customer basis, we certainly have requests for sharing more detailed information with customers, where they may be able to make their own informed decisions as to whether they're comfortable with a higher mating repetition cycle. Again, we're quite conservative in the factors that we consider when we place that on there. I had discussions internally as recently as last week on that same subject. So I think you can, maybe leave a little bit of judgment as to those published cycles. Certainly, they represent the very conservative lower end of what is actually practical. And again, please reach out to us if you have specific implementation details that you can share with us, and we can give you more official feedback still on where we would come down on some of those applications with maybe some higher repetition cycle requirements.
Great. So, Mark, if the customer has a specific requirement, like I'm just making up a number,
500,
like they need 20 cycles, they can
right.
contact us, and we'll work with our engineers to determine whether or not we could, what the chances are of doing that.
Exactly. We can be a little more transparent with this, actually, what our testing involves, and they might agree that it looks pretty conservative. Okay,
good. Since we've been talking, there's one more question that has come in: is there an increased retention force for the U.FL available? Somebody needs a higher retention force.
Well, that's an easy one. If you recall, and you'll see on the slides if you request them, we went back and redesigned the U.FL plug. That's the part with the cable attached to it that plugs into the receptacle. And I don't think I mentioned it, but it actually, and maybe not quite doubles, but maybe nearly doubles the retention force versus the original U.FL. So that would be the obvious option to consider, is looking at our U.FL-A, which again mates to the same existing U.FL receptacle on the board, but in addition to doubling the frequency capability, also I think close to doubles the retention force of the mated pair.
Great. Okay, I think we're about out of questions at the moment, so we'll kind of wrap it up here. So I'd like to thank you all for joining us today. We'll hope this webinar has been informative and you've gained some ideas to help you with future consumer electronics hardware designs. And don't forget to follow Hiroshi on LinkedIn. Good day and stay safe. Thank you. Bye-bye.